Okay, today's lesson is 4.6b, inverse trig functions, and this time we're talking about compositions of trig functions. So remember, a composition of functions is when we take the results of one function and apply it to another. So this is when we generally have multiple parentheses, and when you do, you want to start from the inside and work out, just like any grouping symbols and symbols in your order of operations. Now, one of the things to know is that when we are composing inverse functions, we talked about this a lot previously with exponents and logs and even before that. But if you're composing inverse functions, you always get what you started with. So keep in mind, when you see something like this, the answer is X. Any of these, okay, or any of these, the answer is whatever you started with. Whatever this is, that will be your answer, as long as this answer is in between these values. Okay, the sine function and cosine function have to be between -1 and 1. Tangent can be between anything. Okay, inverse sine has to be between these two. Inverse tangent, that's that little circle that I would draw, and I put the cosine on the first and the second quadrant, and the sine and the tangent in the first and fourth quadrant. So you're going to see as we go through that that's what you have to check. Okay, so let's look at the problems that we have. Find the exact value of each expression if it exists. Okay, tangent, inverse tangent, those are the same function. Is this in my range? Well, any sine or cosine, y'all, any of them, if it's a positive and it's just pi over the number, then yeah, that works, and that's in our domain, in our range of the problem. So yes, it's just pi over 3. Okay. If you want to take it step by step, you can, but these are the easy ones. Okay. Inverse cosine of 3 pi over 4. What quadrant is 3 pi over 4 in? It's in the second quadrant. Cosine works in the second quadrant, so it's just 3 pi over 4. Okay. Arc sine of the sine of 2 pi over 3. Now you want to put down 2 pi over 3, but 2 pi over 3 is in the second quadrant. And if you remember, when I drew the little image to help us remember, sine has to be between these two, in these two quadrants, between negative pi over 2 and positive pi over 2. Well, 2 pi over 3 is over here. Okay, that's not in the quadrant. So I have to find the one in one of these two quadrants that matches that. Well, sine is positive here, so I need a positive sine value, so I need this one. So that means that my answer is going to be pi over 3, because 2 pi over 3 is not in our range. Okay, so that's the only thing you got to watch out with these. Okay, sine of the inverse sine of 4/5. Is 4/5 between the acceptable values of sine? Well, sine has to be between 1 and -1. 4/5 is between 1 and -1. So 4/5 is my answer. Okay. Inverse sine of the sine of -2 pi over 3. Well, anytime you got sine and tangent, if there's another number up here, it's not your answer. Okay. So -2 pi over 3 is down here. So the one that's going to be the same, give me the same sine value, is going to be in the fourth quadrant, and that's going to be -pi over 3. Okay? All right, look at these. So those all dealt with the same trig functions. Tangent, tangent, cosine, cosine, sine, sine. All right, now we're going to deal with ones that they have different trig values. Okay? So when you do these you definitely need to work from the inside out. So I'm going to say inverse cosine of sine of pi over 3, I'm going to go figure out what is the sine of pi over 3. Okay, so I'm looking at my unit circle. Sine of pi over 3 is right here. And the sine is the square root of 3 over 2. So I'm going to go back here and fill in square root of 3 over 2. And now this says, what angle has a cosine of the square root of 3 over 2? So if I go back, cosine is the x coordinate. So which one has a cosine of square root of 3 over 2? That is pi over 6. Hit the wrong button there. Okay, so my answer is pi over 6. All right, this one, sine of the arctangent of 5 over 12. Well, that one's a little different because it's not on my unit circle. There's nowhere do I have the tangent value of 5 over 12? 5 over 12. So this one, you want to remember what sine equals in terms of x and y. And the sine is y over x. And we have that relationship of x squared plus y squared equals r squared. So I'm going to plug in 12 for x and 5 for y to find out what r is. R squared is 169. So r is plus or minus the square root of plus or minus 13. Now, because when you take the square root, you've always got to remember plus or minus. However, r is always positive. So now that I know a value, I know what y is equal to, I know what x is equal to, and I know that r is 13. So what is the sine in terms of x, y, and r? Well, the sine is y over r. And so that's going to give me y, which is 5, over r, which is 13, and we have 5/13. Okay? So if this value is not in the unit circle, you have to go through this process. All right, last two problems. Write each expression as an algebraic expression of x that does not involve trigonometric functions. Okay, so when you're not actually dealing with numbers, okay, you can't really do the intermediate steps. So what you want to think about, arc cosine of x, sine of the arc cosine of x. Well, x is x over r. And if I only have one thing here, that's x. X is the same thing as x over 1. And if you're not dealing with numbers, I would encourage you to use the triangle. So this is a triangle. It's for those positive values because I'm in the first quadrant and it works for everything. And I know that the side adjacent to theta is x and the hypotenuse r is 1. So I need to go figure out this side. So using my Pythagorean theorem, I'm going to go with x squared plus y squared equals r squared. I'm solving for the y. This is the y value, okay, that vertical or the missing side here. So y squared equals r squared minus x squared, or excuse me, 1 minus x squared because r was 1. And y equals plus or minus the square root of 1 minus x squared. Well, I'm in the first quadrant, so I want the positive value. Sine is y over r, and my y is square root of 1 minus x squared, and my r is 1. So that's my answer. It's that over 1. All right, last problem. Again, I do not have any numbers in this problem, so I'm going to go look at this inside and say inverse sine of x. And I know that this sine deals with y over r. X is like x over 1. So I'm going to go draw my triangle. And my y, okay, my y, which is the side opposite theta, is x. My r, or my hypotenuse, is 1. And I'm looking for the other side, which is the adjacent side. So this is just like this triangle here, y'all. So just to save some time, that means this missing side is the square root of 1 minus x squared because we just did it all right here. So what is cotangent? Cotangent is x over y. And so what is my x? My x, which is my adjacent side. So it's kind of tricky, y'all, when they put an x here for the sine. But cotangent is x over y, or adjacent over opposite. So the adjacent side is the square root of 1 minus x squared, and the opposite side is x, and that is your answer. Okay, I hope y'all thought that was loads of fun. If you have any questions, please don't hesitate to contact us or come see us. Thank you so much, and y'all have a great day.